So here we were trying to find out the value of the acceleration due to gravity. And for this, we were determining the force between the Earth and any object of mass m which is placed on the surface of Earth, right? So if we use the formula F equals to G m1 m2 over r square, so we get the force between these two objects as F equals G m over r square, where capital M is the mass of Earth, small m is the mass of object, and the r is the distance between the mass and the Earth. And here we see that that distance is equal to the radius of Earth. So, right, everyone has understood up to this much?
Yes.
Okay. So here we understood that the force between the Earth and this mass is F equals to Gmm by r squared. Now, if we move to the Newton's laws of motion, over there by the second law of motion, we have that the net force acting on an object, the net force acting on an object is given by mass times acceleration. This is from the second law of motion.
Yes, sir.
Okay. So from the second law of motion, you have F equals to Gmm by F equals to Mn. Now, since on this small mass m, a force of Gmm by r square acts, so therefore, we can also calculate the force by using the formula force equals to mass into acceleration, right? This is our first equation. This is our second equation. So if we equate both of them, we get here that Gmm over r squared equals m into a.
Sir, how is that possible though?
Yeah.
How is that possible?
How is that possible? By both, we are calculating the amount of force experienced by the mass small m by two methods. Okay. Whenever there will be a force acting on an object, suppose it's like this. Okay. Suppose if you have a mass over here, you have a mass over here, right? And Earth is attracting this object towards itself with some force F. Right, Chaman?
Yes, sir.
Okay. So so this is the force which is being acted towards the Earth. So Earth is attracting this mass towards it. That means this mass, small m, it is experiencing a force towards the Earth. And we know that force is also equals to mass into acceleration. If there is a force, whether it be gravitational force, whether it is an electrostatic force, whether it is a force by push, whether it is a magnetic force, any force, whatever force is there, but if there is a force, that force must produce an acceleration, and therefore force equals to mass times acceleration. Right? So it does not matter whether it is a gravitational force, whether it is a magnetic force, or whatever force it is. But if it is a force, it must be equals to mass into acceleration. Right, Chavan?
Yes, sir.
Okay. So since it is a gravitational force, but still the force will be equal to mass times acceleration. So hence we can put here that Gmm by r squared should be equals to mass times acceleration. And in this way, both these masses of small m, they get cancelled, and we have the value of acceleration as Gm over r squared. Right? So from this, we already know the value of the gravitational constant.
Yeah, 9.8
Yes. Yeah.
or 10.
We know the mass of Earth. Okay. We know the value of gravitational constant. We know the value of the mass of Earth, and we also know the distance r. That is the radius of Earth. So hence, there are 2 points to be noted. First of all, that this acceleration that is being brought about. So this acceleration, it is independent of the mass. This acceleration is independent of mass. There is no role of the mass. That means if you place a heavy object or a light object, both the object, they will fall towards the earth with the same acceleration. They will have a same acceleration. So towards the earth, all of them, they are going to experience the same amount of acceleration, and it only depends on the distance between the object and the earth. Right? So the distance between the object and the earth is written by the symbol r. But here, since we assumed that the object is lying on the surface of earth, therefore we know the value of r to be equal to the radius of earth, and hence if we calculate this value, this would be equals to 6.7 into 10 to the power minus 11, that's g, multiply mass of earth, which is 6 into 10 to the power 24 kilogram, divided over r squared. The r is 6.4 into 10 to the power 6 meter. Okay. So in this way, if you solve out, if you calculate this value, I would like you people to calculate. So can you calculate all these values? Let's see how you can calculate. Again, this is a practice for your calculations. Do this. Siddhant, your camera is not on. Neha, are you calculating?
Yes, sir.
Okay. So I'm also solving side by side. You should also solve. And if you observe, you'll get the value here 6.7 multiply 6 multiply 10 to the power 24 minus 11. Then here you have the square of 6.4. That means 6.4 into 6.4 multiply 10 to the power 12.
The value is 9.8, right?
Yeah, we know that the value is 9.8, but are you getting the same value? By calculation, are you getting the same value?
Yes, sir.
Wait,
Okay, so calculate it and check. You'll see you get 6.7 into 6 divided over 6.4 into 6.4. Multiply, you have 10. Okay. So now you just need to perform these calculations. Multiply 6.7 into 6 divided by 6.4 into 6.4. Okay. So just a simple calculation. If you multiply and divide, you will see you are getting somewhere 9.7 something. Are you getting that?
Yes, sir.
Okay. So this value, it comes out to be 9.7 something. We take it to be approximately equal to 9.8. So this value of acceleration that we have taken, the value of acceleration comes out to be 9.8 meter per second square. And since this acceleration is due to the gravitational force of Earth, okay, and the gravitational force of Earth, we say we take gravitational force of Earth to be okay. We take this gravitational force of Earth to be gravity. We call it as gravity. So hence we this acceleration that we are obtaining, this acceleration we call as the acceleration due to gravity. Okay. So it is the acceleration due to gravity, and we denote it by the symbol g. So this is small letter g. It represents the acceleration due to gravity 9.8 meter per second. Okay. Now what will happen if the distance between the object and the earth is too large? Okay. So no doubts up to here. Okay, what are the factors on which this acceleration due to gravity depend, and what are the
Sir,
conclusions from it? Yes.
sir, I lost it. I lost my answer in the calculation. So can you show the calculations?
Okay, I have not performed the complete calculation. It's here. The value of acceleration due to gravity is 6.7 into 6 divided by 6.4 into 6.4. So this value will come out like this.
40.02 divided by 40.96.
Yeah, you will have here 6.7 multiply 6.7 multiply 6, right? So this is your 40.2, and it has to be divided by 6.4. Divided by 6.4, you get this. Okay, it was 40.2 divided by 6.4, right? You get your answer as 6.28. Again, you divide it by 6.4. Okay. So this value will come out something to be 9.7. Okay, if you calculate this value. Here you will be getting
Okay, sir.
0.97. So 0.97 multiplied by 10, you will get as 9.77 something. That we approximate it to be 9.8. Now the value of this acceleration due to gravity is not same everywhere on the surface of Earth, or even on the surface of the Earth, it would be changing at different places. On the equator, the value of the acceleration due to gravity is the least, but on the poles, the value of acceleration due to gravity is maximum. Okay, so acceleration due to gravity is maximum on the poles and minimum on the equator. Also, it may differ from the value of acceleration. It will be this we have calculated for Earth. Similarly, if an object is lying on the moon, so its value will be something different. If suppose an object is lying on moon, okay. So suppose now you go to moon, actually. So on the moon, what will happen to the acceleration due to gravity? What would be the formula? Yes, what would be the formula? So now here again, if I want to find out the acceleration over here on the moon, so acceleration on the moon will be equal to the same formula gm over r squared, but now the m will be the mass of moon and r will be the radius of moon. Okay. So understood this, that value of the acceleration due to gravity will be different on the different planets. It will be different on the different surfaces. On the Earth, the value of acceleration due to gravity is 9.8. Okay. And just for your memorization, you can remember that acceleration due to gravity on moon is equal to 1 over 6th of acceleration due to gravity on Earth. This we denote it by the symbol g. So if you calculate the acceleration due to gravity on moon would be 1 over 6 times of 9.8. Okay. This will be the acceleration due to gravity on moon. So that means on the moon, a person can jump higher. On the moon, a person can jump higher, but on the earth, the same person will be jumping lower. If the person goes to other heavier planets like the Jupiter, where the acceleration due to gravity is still more. Okay. On the sun, the acceleration due to gravity is still more. So the jump of the person will reduce. Okay. So acceleration due to gravity, it's not a universal constant. It varies from planet to planet. Even on the surface of the earth, it is different. But roughly for the surface of earth, we take it to be 9.8. So this first point is clear that acceleration due to gravity, first point was that it is independent of mass. Acceleration due to gravity is independent of mass. And second point is that it is different on different planets. It is different for different planets. So different planets, they have different. So it is different for different planets, right? Now, what do we mean by the first statement? We will conclude with the first statement. See that acceleration due to gravity is independent of mass. If anyone is having any problem, not getting, so that person can speak up. Okay. We will
No,
see the
sir.
meaning of, yes.
No, sir, we get it.
Okay. So for the first point, let us understand the first point. So for the first point, it means that if you have the surface of the earth, now this is the surface of earth, and there are two objects. Let's say you have an object of lesser mass and an object of heavier mass. Okay. So there are two objects. So what will be the acceleration due to gravity that is acting on this object? Yeah, Siddharth, how much will be the acceleration due to gravity acting on this smaller object?
Sir, 9.8 meters per second.
9.8. So on this mass, there will be an acceleration of 9.8 meter per second. I remember this is acceleration. Acceleration which we studied in the chapter motion, that same acceleration is 9.8 meter per second square. It's no different acceleration. It's the same acceleration but we denote it by the symbol G and its value is 9.8. Okay. And Abhinav, what will be the acceleration on this heavier mass?
Same, sir.
Same. So both will have the same acceleration, 9.8 meter per second square. Okay. And let us say I drop them at the same time. So if I drop them at the same time, they will have their same initial velocity, which is 0. Right, everyone? Okay. So when they are falling from the same height, so this object also falls over here. This smaller object, it also falls over here. Okay. So both are falling through the same distance. Now, which object will fall earlier?
Same time.
Sir, the
They will
heavier
take
object.
the heavier object will fall earlier.
Yes, sir.
Sir, same time.
Same time.
They will both will take the same time. Okay.
Sir,
Whether it be
because
the heavy object or be the light object, both of them will be taking the same time. You can check it through your calculations, right? Both of them will traveling the same distance s. They both are traveling the same distance. They both are having the same acceleration. They both are having the same initial velocity. Therefore, both of them will be taking the same time. Okay. So both will fall within the
Sir,
same time. Yes.
sir, I have a question. Does the
Yes.
weight of the object matter?
No, the mass of the object does not matter.
Sir, I saw this YouTube shorts where this guy dropped a spring and a ball at the same time, but the spring took longer to come down.
Yes, even if you drop a feather and a brick, okay, so obviously the brick will come faster. This
No,
is
but
what we
spring
observe.
came down later, but he left it at the same time.
Okay, what he did?
No, he dropped the object and then a spring at the same time, like same nanosecond, everything. But
Yeah.
the spring came down later.
Okay, so that's what I'm saying. That's what I'm saying to you, that if you drop a feather, right? If you drop a feather, so here you are dropping a feather and you are dropping a stone. Okay, so of course the stone will reach the first on the ground. The feather will not reach. The feather will take a longer time to reach the ground. This is what we are observing. If you drop a wrapper of your chocolate and a stone, so what will happen? The stone will come faster. So this was what everyone was believing. This is what everyone was observing. Okay, but later it was the scientist Cavendish. See, theoretically it was proven that both the objects will take the same time. It was said by Galileo that both the objects will take the same time, but it was Cavendish who proved this experimentally. Okay, so do you think
Oh,
what would have happened?
different
Yes,
generations at this point. They proved each other wrong in different generations.
no, they didn't prove it wrong. Cavendish proved it that both feather and stone they fall at the same time. He did it experimentally. So the problem was that Cavendish carried out this experiment in vacuum, whereas whatever we observe it
Oh, no,
in
there is there
air.
nothing.
Okay. So there is air which is offering some resistance.
Air is
Okay, so due to air resistance, the stone is falling early and the feather is taking a longer time to fall down. Okay, so Cavendish did this experiment. He created a vacuum, and in that vacuum, he dropped a feather and a stone, both from the same height and at the same time.
But if not in a vacuum, the stone will always drop faster.
Yeah, in the vacuum, both will drop the same time.
But outside the vacuum, the stone will always come first.
Yeah, if outside the vacuum, the stone will always fall faster due to air resistance. Okay, so if this experiment was carried out on moon, So there also it would happen the same thing. There both the object will take the same time. As on the moon there is no air. Okay. Since there is no air on the moon, so therefore on the moon both the objects will take the same time. Okay. Now we will see. Just by taking some of the examples, we will solve a few questions. Okay. As we have seen for the equations of motion, we know that the equations of motion are like V equals U plus ET. This is the first equation of motion. We have the second equation of motion, S equals UT plus 1 over 2 AT squared. We have 2AS equals V squared minus U squared. Okay. So these are the three equations of motion which we have studied. Right? So the three equations of motion, they can be applied with gravitation also, but just by taking the value of A to be equal to G. So the same equation becomes over here, V equals U plus GT. Or S equals UT plus 1 by 2 GT squared. Okay. And the last one, 2AS. So it will be 2GS equals V squared minus U squared. Okay. Or you can take the displacement to be equal to height. So the equation second will be something like this, that H equals UT plus 1 by 2 GT squared. Understood these concepts?
Yes, sir.
Yes, sir.
Now, here is one more thing. We need to see about the direction. Okay. So what we need to see about the direction? During the upward motion, when an object is moving to up. So during the upward motion, we observe that the object is moving up. So the object is moving up. This is the velocity, direction of velocity, but the acceleration due to gravity, it is acting in the downward direction. Right? So acceleration due to gravity, that is acting in the downward direction. Since both of them, they are opposite to each other. Okay, the ball is moving upward, the acceleration due to gravity is downward. So both are opposite to each other. Hence, here we take the value of acceleration to be gravity or acceleration to be minus g. Instead of acceleration, we write minus g. In these equations of motion, at the place of acceleration, we write minus g during the upward motion. Okay, and during downward motion, so if you are calculating for the downward motion, so during the downward motion, we observe that the object is moving in the downward direction. So this is the direction of velocity. The same is the direction of acceleration. Okay. So velocity and acceleration, they both are acting towards the same
So
direction.
small g will be, what's the value of small g? 9.82, right?
9.8. Okay.
So,
So
but
you
then
will
we
be
can write 10, right?
no, we will be writing as 9.8 unless stated in the question. Unless it's given in the question that you have to take the value of G as 10, then only you will be taking G as 10.
Okay, sir.
So see here, during the downward motion, we observe that the velocity and acceleration, they both are acting in the downward direction. So here we take that our acceleration to be plus G. Okay, both are in the same direction, velocity and acceleration, then we take the acceleration to be positive. And if velocity and acceleration are opposite to each other, then we take the acceleration to be the negative. Okay, understood this? Yes,
Yes.
understood? Okay. Now let's move to the next to just one problem. We will see and try to solve a problem. Teacher. Uh, Solve this question number 15. Read question number 15. A stone is thrown vertically upward with an initial velocity of 40 meter per second. Taking g equal to 10 meter per second square, find the maximum height reached by the stone and what is the net displacement and the total distance covered by the stone. Oh, this is simple. You will be calculating the answer to question number 15 and I will check the solution in your notebook. I will see your notebook. So try doing this question in your notebook. Once you have completed question 15, show your answer. Just tell me, prompt me that yes, you have done. It will be checked and then you will be showing question 14.
So are we supposed to do 14 question first?
First question 15.
Sir, can we take gravity as 10 meters squared?
It's given in the question, taking GH equals to 10 meter per second square. So you have to take the acceleration as 10 only. Who has calculated? Rikshit?
Sir, I'm doing it, sir.
Okay.
Sir, done, sir.
Okay, so can you show your notebook? Just wait.
Sir, I think it's not that clear.
Okay, just wait. I will be. It will be clear. Let me hold it
Sir,
over
I'm
there. Okay.
almost done. 1 second, 1 second.
Okay. So you are getting the. Yeah, it's not coming clear still. You are getting 80 meter.
Yes, sir.
Okay. Okay, fine.
Sir, even I'm done.
Okay, those who have done can show. Charan Kaushik. Yeah. So initial velocity 40, acceleration is -10. Okay, so you get 80 meter. Fine. And what is the net displacement? What is the net displacement?
The net displacement.
Yeah, I think it's also asked in the question, net displacement.
Yes, sir.
0.
Sir, it'll be 0.
The net displacement will be same as the distance, right?
No,
Because it is not coming back.
Yeah,
it's
it's
coming
0.
back. The net displacement will be
No, but
0.
it comes back from the same area, so the thing will be 0 only.
Okay,
Sir,
so if it
yeah, it'll be 0.
So
Sir,
they did
can
not
you see
mention that.
can you see my screen?
who is showing? Okay, Rikshit. Yeah, Rikshit. You got net displacement, total distance, fine. Rikshit, you are correct.
Okay, sir,
Smith?
thank you.
Smith, can you show yours?
I'm not able to. Sir, when
Okay,
it's
you are not able.
vertically, its velocity is 0 only.
Okay, Smith, you are not able to get it. And anyone else who is not able to get Siddhant? Siddhant, have you done?
I got it, sir.
Okay, and Siddhisri? Siddhisri,
Sir,
what
I'm
about
not able
you?
to get it.
Send it in WhatsApp.
Okay, fine.
Sir.
Only Smith is not getting. Who else?
Sir, Abhinav, I'm not
No,
able
I
to
just
get
got
it.
the answer. Sure, sir.
Abhinav. Okay, fine. So let's see how do we solve this.
Sir, I just got the
I'm
answer.
showing the solution. Okay, I'm showing you here the question. It says a stone is thrown vertically upward with an initial velocity of 40 meter per second. Okay, so let's first understand this problem. Suppose this is the surface of the ground from where you are throwing a stone. Okay. So here you have a stone and you throw it vertically upward. So your stone, it is thrown vertically upward. It is thrown upward with some velocity of 40 meter per second. Right? Now taking g equal to 10 meter per second square, find the maximum height reached by the stone. So here we observe that the acceleration due to gravity, it is acting in the downward direction. Acceleration always acts in the downward direction over here, and acceleration due to gravity over here will be a negative 10 meter per second square. Yes, Abhinav and Orosmith. Orosmith, have you understood?
Yes.
Okay. Now see, when it moves to the height, if you have ever thrown a stone, if you throw a stone, so what happens? The stone travels to certain height and then finally its velocity becomes 0. Initially you throw it fast, and as it moves up, when it reaches the maximum height, then its velocity becomes 0. So when it reaches slowly and slowly, its velocity decreases, and then when it reaches the maximum height, once it has traveled the maximum height up to here, then now its velocity is 0. So at this maximum height, the final velocity is 0. Okay. So if you put these conditions, you have acceleration as -10, you have initial velocity as 40, and you have final velocity as 0. And I want to find out this height. So Orosmith, which of the three equations we are going to use? Which of the three equations will hold all these four values?
Sir, we have to use v square equals u square plus 2gs.
Okay, we will be using v squared equals u square plus 2gs, and we will be using this as all the values are present here. We have v, we have u, we have g. We need to calculate s, which is the height. Okay. So our final velocity v is 0 equals u, which is 40 squared, plus 2 times of g. G is -10, and multiply with displacement s. Okay. Transpose this 40 to the other side, it becomes -40 squared equals -20 into s. So it's minus gets cancelled. You have minus of 1600 divided by 20 equals to s. So both, now this 0 cancels, and you will have here -80, sorry, minus and minus, there is no minus, there is only plus. So 80 meter is the displacement. That means the ball will reach a height of 80 meter before its velocity becomes 0. So Orosmith, have you understood this problem?
Yes, sir.
Okay. Now from the top where it has reached 80 meter, so will it remain there or will it fall back?
It will fall back.
Yeah, it will fall back, and when it falls back, again it will reach the ground with the same velocity, right? So one important point to note over in this case is that time of ascent is equal to the time of descent. That means the time it takes to reach the maximum height, it is the same time that it takes to return back to the same, to that point. Both the time are same. Okay. So now do this question number 14. Do question number 14.
Question number 14 was right, sir.
Yeah, question.
So which question, sir? Sir, you're on mute.
This question number 14.
Okay, sir.
Sir, can we take G value as 10?
No, it's not stated, so you will take it as 9.8. Since it's not given, so you will take it at 9.8 only.
Sir, I have some internet issue. What are we doing now? Which question?
Question number 14. a stone released from the top of a tower of height 19.6 meter. First, you draw the diagram, understand the situation, and then solve. Okay. It is dropped. So when you are dropping something, it has its velocity 0. And when you throw an object with a certain velocity, it has that velocity.
So here, do we take initial velocity 0 or final velocity, because both the cases it will stop, right?
See, we consider the final velocity as the velocity with which it strikes the ground, not the velocity which it attains after striking. So the velocity with which it will strike the ground, that is the final velocity.
Sir, I'm done. The second one, do you see it?
Oh yeah, just one minute. So you're getting 19.6.
Yes, sir.
Okay, so let's see. Let's see here. See, this is the ball which is
sir.
dropped from a height of 19.6 meter, right? So here height of this ball is 19.6 meter. We know that height is 19.6 and it is been dropped from here. So its initial velocity is 0. So the initial velocity of the ball is 0 and it has
Sir, can you see my screen?
no, I can't see anyone's screen. Yeah. Okay, you are also getting 19.6.
Yes, sir.
Sir, I got the
Okay.
same
Yes,
answer as
sir.
well.
Okay, fine. So
Sir,
see,
even I got the same.
Sir, me also.
okay, is there anyone who has not understood this problem? Or Smith, have you got the answer?
Yes. Sir.
Okay. So can you show your Aura Smith?
Yes.
Okay, show it.
Remove the blur.
Yeah, it's blurred. No, but but I can't see anything written.
Yeah, it says G something, sir. It's not correct.
Yeah. So I think you have not solved it. Solve it, beta. Aura Smith, solve it. And if you are not able to solve, I'm here to help. Okay. So solve it, Aura Smith, first. Siddhant, even your camera is off. Rikshit,
Sir, is 19.6 correct?
yeah, 19.6 is correct. So Aura Smith, yeah, Aura Smith, if you are not getting, just tell me.
Sir, so
Yes.
sir, I did it roughly, so
No, even if you do it roughly, then also it should be visible, right?
yes, sir. My connection went.
No issues, beta. If you are not getting, just inform so that I can explain you all. Otherwise, I will be moving to the next problem then. Okay. So let's see here. The initial velocity was 0, and we have to find out the final velocity with which it will strike the ground. We want to find the final velocity v. Okay. So what is the acceleration? The ball is moving in the downward direction. So this is the direction of velocity, and the same is the direction of acceleration. So we will take as our acceleration to be plus 9.8 or plus g. Using the equation v squared minus u squared equals 2as. So v v squared minus u is 0 squared equals 2 times of 9.8 multiply s, which is 9.8, which is 19.6. So v squared equals 19.6 into 19.6, and this will be, v will be equal to under root of it, so that will be equal to just 19.6 meter per second. Okay, so everyone has got this correctly.
Yes, sir.
Now do this question number 16, which is from the previous topic. Okay, that's your homework. You will be doing. I think we have done this question, right? Okay, so your only homework is this question number 17. This is your homework.
I'm done with it already. I just did it.
Yeah.
I just did it, sir. Can I show you?
No, not now. But currently, I'm leaving just now for the new class. Okay. So I'll be checking it in the next class. Complete this question number 17 as homework. Okay. Bye everyone. Good night.
Bye, sir.